Hey there, geometry students. Today we're going to continue our conversations about right triangles, and we're going to talk about something called right triangle trigonometry today. So it turns out that in right triangles, there's a relationship between the angles and the ratios of the sides in the triangle. And it can help us do a lot of things like solve for missing angles, solve for missing sides with very little information given, except for the fact that it's a right triangle and maybe one of the sides or one of the angles, things like that. Um, okay. So anyway, uh, first thing we need to do is take a look at a right triangle and remember a few things. So first, if we have a right triangle, maybe that's angle A, B, and C or something like that, we know that there's a name for the longest side, the one that's across from the right angle. We know that that is the hypotenuse. All right, so that's going to remain the hypotenuse. And then we also had the other two sides. Those were called legs. The problem is, in order for us to use ratios of the sides and be very specific about what side we're talking about, we can't just call them legs anymore, because we need to know which leg we're talking about. So all of this is going to be with respect to a specific angle. So anytime you use trigonometry, you're going to be looking at a particular angle and referring to the different sides with respect to that angle. So, for example, if I'm looking at angle A, then if I want to talk about these two legs, I'm going to talk about them as the opposite leg, since it is across from angle A. So this one is going to be the opposite side. And then the one that's next to it is going to be called the adjacent side. Okay, and so that we don't have to continue writing the words opposite, hypotenuse, adjacent, I'm going to show some abbreviations really quick. Hypotenuse will either be abbreviated as HYP or as just the letter H. Opposite will be abbreviated as OPP or just the letter O. Adjacent will be abbreviated as ADJ or just the letter A. Okay. So anytime I talk about some ratios that have to do with the right triangle, it's going to be talked about with respect to a certain angle. And so there's three ratios that we can use. There's sine, cosine, and tangent, and they're also abbreviated as SIN, COS, and TAN. You might have seen those buttons on your calculator before, so now you're going to get to actually know how to use them. So here's what they are officially. The sine of an angle is the opposite over the hypotenuse. The cosine of an angle is the adjacent over the hypotenuse. And usually the way that you will see this written is like cosine of A, sine of A. So the A that we're referring to here is the angle A. And then the last one is tangent of A. And so that one is opposite over adjacent. And it just refers to the side lengths. So for a moment, let's say that this side length is 3, this side length is 4, and this side length is 5. So the sine of angle A would be the opposite length over the hypotenuse. So 3 over 5. The cosine of A would be the adjacent side length over the hypotenuse, so 4 over 5. And then the tangent ratio would be the opposite over the adjacent, so 3 over 4. Okay, so those are things you might be asked for. You might be given all three sides of the triangle, and you might be asked to find the sine, the cosine, or the tangent of one of the angles. And so it might seem like it's a lot to remember, the sine, cosine, and tangent stuff. So an easy way to remember it is with this kind of mnemonic: so, ka, toa. It's what a lot of people like to use to remember it. So it stands for sine is opposite over hypotenuse, since we have sine, opposite, and hypotenuse, SOH. And then cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. So we have so, ka, toa. So that's what a lot of people like to use to help themselves remember. Okay, so now that's great for angle A, right? We've got it all figured out for angle A. We could also be asked what is sine, cosine, or tangent of angle B, though, because those will be different. So for angle B, the problem is if I look at things from angle B's perspective, this side is not the adjacent of angle B. It's the opposite of angle B because it's across from it. So if I'm going to look at angle B instead, then my opposite and my adjacent are actually going to switch. The hypotenuse will always stay the same because it's always across from the right angle. That's how it's defined. But the opposite side for angle B is actually this one. The adjacent side for angle B is actually this one. So it just switches. Okay, so that's going to switch things up here for us if I wanted to find sine, cosine, and tangent of B. So sine of B is actually going to be the opposite over hypotenuse here, so 4 over 5, since our opposite is different. Cosine of B is going to be adjacent over hypotenuse, so 3 over 5. And then tangent of B is going to be opposite over adjacent, so 4 over 3. And if you compare between sine of B and sine of A, you might notice, or sine of B and cosine of A even, that sine of B is the same as cosine of A. And that sine of A is the same as cosine of B. They're both 3/5, right? And then if you look at tangent of A and tangent of B, they're just the flipped fraction, right? The reciprocals. So those are interesting things that we can notice here. So that's how we would use the three sides to find sine, cosine, and tangent of an angle in a right triangle. Okay, so another thing that we can do with right triangle trigonometry is that we can use those buttons in our calculator to find sine, cosine, and tangent of an angle if we know what angle we're dealing with. So these are all things that we would do in a case where we don't know what the angle measure is. But if I do know an angle, so let's say I've got a right triangle here. And I know that this angle is 37 degrees. And what if I were asked what is sine of angle A? Well, I don't know any of my sides, but I know this angle, right? So sine of A is just sine of 37 degrees because the angle goes inside the parentheses. So now is where we bring out the calculator. If you're using Desmos online, you can just type in the word SIN parentheses 37. If you're using a TI calculator, the first thing you want, any calculator actually, you want to make sure that you're in degree mode in your calculator, which most of them come starting out in degree mode. And then you want to hit the button that says sine. It should be around the middle of your calculator. There should be buttons that say sine, cosine, and tangent on them. So hit the one that says sine, then type 37, then hit enter. And you should get a decimal 0.601815, lots of other numbers. So it depends on what you're asked to round to for what you'll put for your final answer. If you want to round to 3 decimal places, you would go 0.602, since the 8 rounds the one up to a 2. Or if you're asked to round to just 2 decimal places, that would be 0.60, or just 1 decimal place, 0.6. Typically, I would like to round to 3 decimal places, but make sure you pay attention to whatever worksheet you're doing asks you to round to. But yeah, so that's another thing that we can do. You could type in cosine of A, you could type in, or cosine of 37, or you could type in tangent of 37, and you would get the decimal ratio of those sides on your triangle. Okay, so that's all for today. Next time we'll have a little bit more on right triangle trigonometry. We'll start actually using our right triangle trig to do something like find sides and angles. But until then, if you have any questions, feel free to send me an email, comment below, or show up to office hours. Have a wonderful day.